Hello, we are from Group 1, and today we are going to present the packet tracer topology for the case study assignment. My name is Jason Anderson Winfrey with student ID 259834141. I will present the topology as student 1 covering core server PC3, Katoomba router, and ISP router. First, we can check the IP configuration for PC3, where I have configured the IP address statically with IP 172.16.65.66 with the appropriate subnet mask and the default gateway 172.16.65.65. Next, I will show you the configuration on the Katoomba router. Firstly, when accessing the console, we are presented with password verification and the banner message. The password here is Cisco, and when going to enable or exec mode, there's also password encryption with password class. Next, I'll show you the running config. I've configured the hostname, the password encryption, the enable secret when going to enable mode, and we can see the interfaces here with the appropriate IP address and also some NATing configuration, which I will talk about more in detail later on. The topology is also configured with dynamic routing OSPF with router ID Katoomba. The router ID is 333, and it has a passive interface of G00, which is connected to the PC3, and the three networks, the PC network, the Lyra network, and the Blackheath network connection. And I've also run the default information originate, which will advertise the gateway of last resort routing, which is connected to the internet. Here we can also see the NATing configuration, where I've assigned a pool of public IP, the 203.0.115.1 through 203.0.115.15 as the public access IP pool. And here I have configured that we will use list1, which permits anyone in the topology basically to access the internet. And there's also a static NAT config for specifically the PC3 device, which is mapped to the 203.0.115.0 public IP. And here's also the banner config. And one thing to mention, the line console is configured with the password and the logging synchronous. Next, I can show you the IP interfaces. Here we can see that all 5 interfaces are up and active with the appropriate IP address. And I can also show the IP protocol command, which is set with the OSPF routing protocol, router ID, and the number of networks all configured in a single area OSPF, area 0 with the passive interface of G00. And I can show you the OSPF neighbors having 111 as Lyra and 2222 for Blackheath. Also, I can show the routing table. Here we can see some OSPF routing as per configured, and the static route to the ISP is configured here to 203.0.113.1. And because of the default information originate command, this should be advertised to the Lyra and Backgate router. I'll just quickly show you. Here we can see the gateway of last resort, and here is that route. Also on the Katoomba uh, router, I've also configured some static routing. Let's run this again. Here we can see that route 000 is routed through the 203.0.113.1 IP, the next hop. This is the primary line, and this is the secondary line, the .5. Here we can see the additional AD config to make sure that this one is preferred. And I will show you the netting config with the IPNet stat command. Here we can see the outside interfaces. These two are connected to the ISP, and the inside interfaces. These three are within the inside of topology, and this is the access list previously mentioned, and the public IP pool of public access. And let's go to the ISP router now. Now the configuration is quite similar here. I'll just quickly show run. The host name, the enable secret, and we have three interfaces for the ISP, the G00 and the serial 000, map to the Katoomba router, and an additional loopback address to simulate the internet. I can show you the routing table here, where we are statically routing the public IP now because this is the outside of the NAT. So any IP here to 203.0.115.0 up until .15 is mapped to the primary connection here. Now I will show you the PC3 that can ping the internet. Oh, first I'll show you the PC3 pinging its own gateway. And then pinging PC1 and PC2. 65.99. This is the IP of PC1. There we go. And PC2 is 66.2. And the internet. There we go. The pings are working. And because we've pinged the internet, let's check out if the NAT is working with the IPNet translations command. Here we can see that 65.66, which is PC3, is mapped to the static public IP 203.0.115.0, and it's reaching the internet. Now, let's simulate the internet, the primary internet connection going down. I will go to the G01 interface and shut it down. Now let's check out the interface. Here we go. This is down. So let's check out the routing table. The gateway of last resort is updated to .5. Remember, this is the secondary connection. And we should still be able to ping the internet. In fact, let's show the trace command that we are pinging through the .5, the secondary connection. We can also see that, sorry, pinging to the internet still works. And there we go. And let's turn the primary connection back up. Now shut command. And let's check out the routing table back. And there we go. The .1, the primary connection, is back as the gateway of last resort. And when pinging again from Katoomba to the internet, let's wait for a bit. Let's try again. There we go. We're pinging to the .1 IP. And that's about it for my section. Thank you.
Hello everyone, my name is Lenzhen Su and my student ID is 261371049. Today I'm going to present and explain the configuration in Student 2, which will include PC1, Switch 1, and LoRa router. Okay, first of all, let's check some basic configuration like hostname and password. Here we use LoRa router to check these basic settings. Here we can see for the security purpose, we have set console password. When we are going to the console, we have to enter the password. And now when we try to go into the enable mode, we also have to enter the password. Now we are in the enable mode. Let's use the command show running to check more settings. Here we can see we have set the hostname as LoRa. And we also set the no IP domain lookup. And here we have set login synchronous, which means it can keep our command line clean by stopping messages from interrupting our typing. Okay, after checking the basic settings, let's move on to the PC host. Here we use PC1 to present. First, let's check the IP address and subnet mask for PC1. Here we use the CLI and enter the command ipconfig to check. Through this command, we can see our IPv4 address here is 172.16.65.99. And also here we can see our subnet mask. And here's our default gateway, which is 172.16.65.97. This IP address will refer to the subinterface for management VLAN in LoRa router. Okay, after checking this, let's see if we can ping to the gateway from PC1 successfully. Okay, here we can see it pings successfully. Now let's try to ping to other PCs in this topology. First, let's ping to PC2. The IP for PC2 is here we can see we get a reply from PC2 successfully. Here, look back to the topology, we can see PC2 belongs to another VLAN named EcoPortal. And why we can pin it to it successfully is because we have set VLAN trunking on switch and we set trunk-based inter-VLAN routing on routers. Also, we set OSPF on routers. For these functions, later we will check this configuration as well. Okay, for the similar concept, so we can ping to PC3. Let's check it. But here we see we pings to PC3 successfully. And also let's try to ping to the internet. Okay, here the first request timeout is because it's our first time ping to the internet. But if after the first timeout, we get the reply successfully. Okay, after checking PC1, let's move on to switch 1. For switch 1, let's check. We have set 3 VLANs and allocate assigned numbers of ports for the VLANs. Here we use the command show VLAN to check. Here we can see we have set VLAN 10 names organic labs here, and we assign the port from FA06 to FA010 for this VLAN. As the instruction says, we have to allocate 5 ports for each user VLAN on each switch. Also here we set VLAN 20 names field ops with 5 ports. After that, we set VLAN 99 names management. For the management, we only specify 1 port for it. And as what we mentioned before, we have set VLAN trunking on switch. Now let's check the configuration. Here we use the command show interface trunk. By this command, we can see we have specified the port FA01 as and active the trunk mode on this port. And here we set VLAN 555 as native VLAN, which means all untapped traffic on trunk port is associated with VLAN 555. And as the instruction says, for security purpose, we only allow non-VLANs. Here we allowed VLAN 10, 20, 99, and 555 on this trunk port. Okay, now let's move on to switch at SVI. Here we assign VLAN 99 as management VLAN, so we assign IP address and gateway for it. Here we use the command show running to check. We have to look for VLAN 99. Here, interface VLAN 99 is the virtual interface in this switch, and we set the IP address and subnet mask here, also the default gateway. Okay, we finish all the criteria in switches. Now we move on to routers. Here we use LoRa router to present. In the LoRa router, we have set, let's check we have set all required interface on this router. Using the command show IP int brief. Through this command, we can see we have set the IP address for GIG0 is here, and we set under GIG01, we set 3 subinterface as 1.10, 1.20, 1.99. And for serial 0/0/0/0, we also have set IP address for it. And in the beginning, these interfaces on router were down by default, but we have set no shutdown on these interfaces. So now the status we can see here are all up. Okay, after checking all interfaces on this router are all functioning, let's move on to the OSPF configuration in router. First, we use the command show running. Now we find the OSPF part, and here we can see we have set these 5 networks. We assign them to area 0, meaning they will be advertised within the backbone area. And now we use another command to check show IP route. Here in through the show IP route command, we can see the routing table for this router. And here for this column, we can see the protocol. O means OSPF, and here we can find this O 5 O protocols record for the 5 networks we mentioned before. And last, let's use the conventional IPOSPF neighbor to check if we learned any neighbors from OSPF protocol. Good. We can see we have learned 2 neighbors from OSPF protocol. Okay, here's the end of my presentation. Thank you for your time and attention.
Hello everyone, my name is Harshavardhini Maniraj, student ID 25379328, and I am going to cover the student 3 section, which is the Blackheath site. And the Blackheath site contains the Blackheath router, the switch S2, and the PC2, which is the eco-porter. And let's now see the configuration and verification of these devices, starting first with the Blackheath router. First, let's type in the password. Now let's see the configuration of the basic commands, which is the host name. To do that, let's see show brand name config. And we can see the host name is Blackheath, and also we have set the password here. And no IP domain lookup is configured. And if we scroll down further, we can also see there is a banner, and also for the console there is a password, and also logging synchronous is enabled. Now there is also inter-VLAN routing implemented on the interface GIG01, which would be this interface. And each sub-interface is tagged with the VLAN ID, which is encapsulation.1q. And let's see using the command show IP interface brief. And we can see all the interface and also the sub-interface, VLAN sub-interface or active in the up status here. And to confirm that the routing between the inter-VLANs are working, let's first try to ping PC2, which is the VLAN 10 in this case. So I will use the command ping to do that. 172. Yeah, now let's try to ping switch to yeah, with these successful pings, we have verified the routing between the VLANs. And now let's see the dynamic routing for which we configured OSPF all in a single area, which is area 0. We can use the command show IP protocols for this. And yeah, we can see all the network has the same area, which is area 0. And also we can see the routing ID, which is 1 and 2 here in this case. You can also see the other router because we have 3 routers here, and the router ID for Blackheath router is 2.2.2. And 2. So yeah, and let's also see another command, which is show IP OSPF neighbor. This is to confirm the neighbors of our router, which in case would be the Lura and Katoomba. To do that, yeah, now we can see this is 1.1.1.1, which would be Lura, and then 3.3.3, which would be Katoomba in this case. And we can use one more command, which is show IP route OSPF. And this will show us all the known internal network routes. So this confirms that our OSPF is functioning. And this is everything for the router. Next, let's move on to our switch. Switch 2. Again, let's do the password first. And let's do the command show VLAN brief. Here in switch 2, we have 3 VLANs, VLAN 10, 20, and 99. 10 is for Eco Portal, and 20 green backup, and 99 is for management. And for each VLAN, we have assigned 5 ports, but only for the management VLAN, we have 1 port, which is for the VLAN 99. And furthermore, let's use the command show interface trunk. So we have enabled security, we have a native VLAN 555 on the trunk of the router, and we only allow the known networks, known VLAN networks, which is like the 10, 20, 99 on the trunk. So we can use this command to see the native VLAN 555 is configured, and we also allow the known VLANs 10, 20, 99, and 555 on the trunk. And also we can use the command show running config to check out the VLAN 99 has a valid IP address and also a gateway. So let's check it out. Yeah, here we can find the interface VLAN 99 and which has an IP address and also a default gateway. And to check it out, let's try to ping it actually. Ping the gateway, which is the gateway in this case would be our router. So yeah, we can see that it can ping the gateway. So and we can now move on to the PC, which is PC2. Let's start with the checking out the configuration. The PC is configured with valid IP and subnet mask and default gateway. And now let's go ahead and check out. Yeah, we are going to check 3 things for our PC. The first thing is if the PC can ping the router, and we also check if the PC2 can ping the other PCs, which is PC1 and PC3 core server. And finally, we are going to check if a PC2 can reach internet. So let's start with the first ping, which is the ping to our router, the gateway to the PC. Starting with the first ping, which is 172. Yeah, now we got a successful ping for the router. And next, let's try to ping PC3 core server. 172.1. Yeah, that's the wrong address. It's 172.16.65.66. Yeah, let's try it again. Yep, we got a successful ping. And let's also try to ping the other PC, which is the PC1. 16, 65, 9. Yeah. And yeah, we got a successful ping. And finally, we are trying to reach the internet. Yeah, now we can see that it's a successful ping. So with this, PC2 can now ping other PCs and the D4 gateway, which is our router, and also it can reach the internet. So this concludes my presentation. Thank you.